I just want to thank Alina Abraham in New Zealand for engaging with my noncommutative music analysis. And we can see here she is a professional music theory teacher, a new model of perception. And then she commented on my posting, once a G is 3, third overtone in the harmonic series, the same G cannot be an undertone of 1, but undertone of 4, in my opinion. Thank you. And then, so this is the key whole question. And so I go into the Phantom Tonic, that the perfect fourth is not an undertone of 4 because that's changing the direction of time. And so Western tonality is not the inevitable result of how we hear, but it's an artificial invention. A fundamental pitch will not produce a perfect fourth above the fundamental. The fourth is an interval approach downwards. And so this means if you play the two of them together, the root tonic is evoked in the sound of the perfect fourth, since the root tonic is a fifth above the fourth. But the root tonic, the perfect fourth, is not in the overtone series, and so it is not evoked in the sound of sa. So if you have two drones, the lower of the two, it's not always the one that will sound primary, but the one that which initiates the overtone series to which the other note belongs. So the perfect fourth initiates the root tonic, but the root tonic does not initiate the perfect fourth. Now it sounds like it doesn't mean anything unless we go into the actual mathematics. And there we find out that the root tonic has to be changed. So instead of taking 12 ninths, which is 3/4 of 12, we take 8/6, which is 3/4 of 8. So it's a different root tonic. And by doing that, we're able to create the very first logarithmic equation of 3/2 plus 4/3 equals the octave. And this is what everybody learns in Western music theory as the harmonic series of ratios. And that's the very foundation of Western science as commutative geometry. And so in other words, we start at 12, we take 2/3 of its length, then we add a length corresponding to 4/3, but this time we are starting not at 12, but at 8 as the root tonic, and we take 3/4 of that. And so 1, 4 equals 7, 5, and this is exactly what Alina is stating. She's saying this exact same thing, that these are equal. But they're not equal, because any musician knows that 1 to 4 is C to F, whilst 7 to 5 is C to G. So they're different. This is what I call the bait and switch. So she's saying that once a G is 3, the same G cannot be an undertone of 1. Right, but the whole point is that the perfect fourth was created from the undertone of 1 as F, as the perfect fifth. And that's why it is an undertone of 1 as the different, as not the G but the F, or the perfect fourth. That's a perfect fifth as the undertone. But she's saying that the undertone of 4 as the octave is the G, but that 4 is not the perfect fourth. It's the same root tonic, changing the direction of time. So in order to get the perfect fourth in the same scale, you have to change the root tonic. So then we have to go to, okay, and this is what's behind the Pythagorean comma, that the notes F and C are the last one produced by the cycle of fifths before the 7 octaves with 12 fifths. So the whole point of the truth, the non-commutative truth in music theory, is when you permute A and B and you make the A pass on the other side, you have to make it evolve with time. And the time in which it has to evolve is in fact the purely imaginary number. This is what is behind the scenes. So that's the non-commutativity. And then my book has more details on that. So this is what's being ignored, is that that permutation between the perfect fourth and the root tonic inherently requires a change in time, which is changing the root tonic. And that's what's ignored at the foundation of Western science for commutative geometry, is they ignore this very simple truth by claiming this is true, but when you listen, this is not true. Based on listening, it's C to F and C to G.